know, Professor Iles is assistant professor in environmental science policy management here at Berkeley, a very cherished colleague in the science studies community here. Alastair does a tremendous range of work dealing with issues of sustainability in many of its guises, and he has a new big project on green chemistry for which he just received an NSF grant, so congratulations. And he's going to talk today about how to get people to want to green their chemistry. And I believe Nicholas here will be Patrick is going to be reading it.
You're not yet. It was Nicholas and he had to go to the doctor.
So Patrick is going to be delivering Alastair's paper, and Alastair will be here to field questions, etc. I think you should do it, actually.
That's what after.
Here's water.
Yeah, hi, I'm Patrick. I'll be Alastair's voice for today, so without further ado, I'll just dig into it. Today I will look at the possible role of affects, or emotions, in greening chemistry. Alastair asked me to read a slide here. It's kind of hard to see, but it says safe, tested, proved in the blue text there. Briefly, green chemistry means the redesign of chemical molecules and processes to be less toxic and more sustainable. Green chemistry is a realm of science, policy, and business. Changing the chemical industry is ostensibly only about developing new technologies, business strategies, and engineering systems. But as this picture shows, many children, including Alastair himself here, first learned about chemistry through the sights, smells, and sounds of home chemistry experiments. This picture, though, is a parody from a chemist who complains that there's no more danger in these home kits. And again, draw the attention to the safe, tested, approved. From the viewpoint of many green chemists and policymakers, they may be mystified as to why I'm raising the topic of emotions. What place do emotions have in green chemistry? Isn't affect potentially treacherous and unscientific from an epistemic standpoint? However, I'm not simply talking about how people feel about chemicals and how this may contrast with the dominant technical discourses of chemistry. I'm talking about the relationships of affect that may develop around chemicals, such as parents worrying about their children being exposed to products, or residents choosing to become civic scientists to help protect their neighborhoods, or chemists and managers starting to think about the risks that their decisions are creating for other humans and ecosystems. These relationships may play a central role in reshaping the landscape of chemistry. My talk is speculative. I would like to use this gathering as a chance to start thinking about a different angle that complements my research with policy, law, and social science issues of green chemistry. I just received an NSF grant to develop a new course in the public ethics of green chemistry at the Berkeley Center for Green Chemistry, where I am the Associate Director for Law and Policy. As part of this ethical envisioning, I'm curious about whether and how the ways in which we experience green chemistry might provide insights into politics and policy of changing one of our most entrenched production and consumption systems. This raises anthropological, psychological, philosophical, and sociological questions that you all can help with. So right now we're going to run through a set of images that are associated with chemistry. And I'd like to hear from you a few examples of your reactions to each slide. And we'll just call on a couple people to just please say what you think in one sentence. Alright, so this is a chemical reaction equation, hydrogenation, and that's a chemical molecule structure for caffeine. Because I need. So, any thoughts or? Boring. Boring.
Okay. Here, I'll write a couple down. I'm going to say complicated.
You're going to say boring? Yeah. Complicated? Structured? Structured. Symbolic. You can put together more than one word. If you want, please don't feel limited. I don't feel qualified to be complicated. I don't.
Nice.
Right, so.
The caffeine structure does something to us.
You know, but you're looking at it up there as a representation on paper.
Wait, say it again. Caffeine structure does something to us.
Yeah, and then it's represented there on paper.
Okay.
Interesting.
That's pretty good. So let's go on to the next slide here. Now this is a chemist who is making a new synthesis. So again, responses to this.
Which reminds me of an ad in the Journal of Science, probably trying to solve PCR thing. Yeah.
Labs are never that clean.
Yeah. Especially jackets.
There's a little looks like another tomato.
What was that?
Like another tomato.
Yeah.
False.
Yeah. Yeah.
So on the next one, this is a giant BASF factory in Ludwigshafen, Germany.
Wow.
Dirty clean.
Massive integration.
Massive integration.
EASF, a chemical company. Yeah. All machines, no people.
Where are you?
Looks immovable. Looks entrenched.
Where are you?
Yeah.
No smoke.
Yeah, I was going to call it something like neo-industrial.
Macro set.
Photoshop to image.
Yeah.
So this is an example of the chemical-based products that you can find in your own home, in your daily life. Yes, please.
Rabbit.
Oh, yeah.
Animal testing.
Generic.
Kid friendly.
Mother of
Standardized.
Mother Earth.
Mother approved.
Mother.
Very soft.
Yeah.
Soft.
Yeah.
Yeah.
Soft.
All right, so we'll sort of conclude a little audience participation and resume the talk. As you can see from this unscientific survey, supposedly lay people can vary in their relationship with chemistry and chemicals, and the differences between these examples are stark. Most people may feel marginalized by the first slide, but perhaps more comfortable with the personified chemist. The factory may cause trepidation or be seen as a sign of economic wealth. Products may be taken for granted. Chemists and managers may have differently hued experiences, but they too are likely to feel variably across the examples. So first, I will give you some background context on the chemical industry and what green chemistry refers to. Existing industrial chemistry uses non-renewable petrochemicals to make millions of tons of over 80,000 chemicals every year, generating hazardous pollution and waste. Reagents are added to petrochemical feedstock, and the resulting intermediate compounds are put through reactions, using vast amounts of energy to produce a chemical that is incorporated in products such as computers or clothes. The chemicals are used and released into ecosystems and human environments without knowing their longer-term effects. Historically, chemists have designed chemicals without evaluating their environmental and health impacts, and with little accountability to societies for their choices. This production system is deeply entrenched and intertwined with the regulatory system that historically has favored incumbent technologies. In contrast, green chemistry aims to factor environmental and human health concerns into molecular design. Since 1990, a new social movement of chemists established green chemistry as a solution to the toxicity problems of the chemical industry. The US EPA has defined green chemistry as an effort to, and I quote, promote innovative chemical technologies that reduce or eliminate the use of or generation of hazardous substances in the design, manufacture, and use of chemical products. In 1998, two leading chemists, Paul Anastas and John Warner developed the 12 principles of green chemistry to guide the work of the green chemistry movement. For instance, chemists should design chemical syntheses to prevent waste, leaving no waste to treat or clean up. As a quote. As you can imagine, there are diverse ways to construe what green means. It's a contested term that can stimulate a spectrum of emotions. Traditional chemists may regard green chemistry as a scandalous politicizing of their work. Activists may argue that chemists aren't serious about protecting human health. Managers may say that green chemistry doesn't make enough money. Some chemists see green as limited toxicity, whereas others urge a society-wide transformation into sustainable civilization. I've come across all these emotions during my research interviews. In the last 20 years, green chemists have produced many innovations, ranging from removing toxic solvents and dry cleaning to instigating research teams within companies. In 2008, the California state legislature became the first state to enact green chemistry laws, requiring manufacturers to do life cycle assessments of chemicals and to evaluate alternatives to hazardous substances. Nonetheless, green chemistry hasn't yet made deep inroads into the chemical industry, let alone the consciousness of consumers and citizens. Right. We're going to pause again. I'd like to ask everyone here, who has heard about green chemistry prior to this talk? Could you please raise your hands? So if you have, if we could just get an example or two of where you've heard about it.
It's a massive presence on campus. I mean, there are several talks a week on it at this point. There's a gentleman called Mulder, who's actually one of the major bodies behind it. So I also was Science and Technology convener for the Irish Green Party. We're great, so there's a lot of
Yes.
Professor Amy Iles from policy class. I'm a PhD student in environmental health.
I'm sorry, who's the?
Amy Iles,
Amy Iles.
K-Y-L-E.
So two academic settings, a political party setting, and anybody with a different exposure pathway.
Well, some of my father's work was kind of early on in the 60s, with kind of following some of the disulfides in detergents and algae blooms and kind of the policy, driven things that were kind of headed by Ralph Nader early on to change those things.
I could add biofuels and petroleum, petroleum replacement.
I also just like to point out we also have a real chemist here. Hopefully will contribute his views.
biodegradable beer glasses, we hope.
Okay. Well, thank you all for that. I think that was pretty helpful. Bit of input there. I think we'll move up. So, in general, clearly not everyone has heard of green chemistry, and there are various reasons for this lethargic take-up of green chemistry, particularly in the U.S. For example, the matrix includes a weak political movement demanding green chemistry, a lack of industry accountability for design decisions, little knowledge about chemistry beyond the early years of high school, a flawed and reactive regulatory system, a feeble market due to poor information for consumers, and a professional chemist culture that discourages taking toxicology into account when designing molecules. I investigate all of these reasons as part of my research. However, I also speculate that part of the reason is that little attention has been devoted to what and how we feel about chemicals, to how we collectively and individually form experiential and memory-permeated relationships with chemicals through products we use in the environments we live in. Here I'm channeling what Donna Haraway says about the place of dogs in our culture, what Sherry Turkle thinks about the importance of objects in our memories, and what Mary Douglas wrote about the role of cleanness eco-friendliness in our lives. Most people don't understand what green chemistry means, or feel enthusiastic or hopeful about its potentials, even if they only vaguely know about the field. In the case of consumer electronics, we witness euphoria about iPhones or electronic readers, obsessive tracking of new products as they enter the market, and remolding of our social interactions and everyday practices around these technologies. Yet we don't observe this delight or desire for green chemistry. Even though ironically these technologies may use green chemistry inside, people don't engage with what green chemistry can offer. Consumer demand is only one instance of the emotional dimension of chemicals. Alastair has another point. I can empathize with this consumer enthusiasm for electronics. I just bought an electronic reader, a Nook, I believe. Here I would like to mention 3 theoretical points about emotions and relationships of effect. First, what are emotions? There are very old debates regarding this question in philosophy, sociology, neurology, and psychology of emotions. Emotions can be categorized in numerous ways. I just want to note that our emotions emerge from complex interplays between neurology, personality, physiology, cognition, and behavior. Not to forget social and organizational settings. Emotions may come from our body sensations, for example, smelling a pungent chemical, or from observing or engaging with objects and events around us, for example, watching a janitor clean a floor, or listening to a relevant talk. Individuals can vary greatly in their responses to something because of how they experience it. Second, what do emotions reveal about us and our perceptions of the world? We are populated with emotions. They pervade our lives and communities. And by we, I mean all the humans that comprise our society in all their cultural, ethnic, socioeconomic, professional, cognitive, and gender diversity. Emotions influence how we interact with each other and our environment. For example, how we regard, accept, or reject technologies as part of our lives may result from our feelings about their characteristics, perceived risks and potentials, the ways in which the technologies have been introduced, whether other people or communities are using the technologies, and what we think the consequences may be. How humans view the makers of science and technology may also be deeply emotional. Can we trust chemists to design safer molecules? Do we exalt them as scientists and therefore immune to societal criticism? Importantly, emotions may also play a role in influencing the development of governance processes for technologies. For instance, whether lay people believe that they can play a role in helping set priorities for green chemistry may depend on their developing confidence and motivation, which involve emotional responses. Which brings me to the third and most critical point, which is that emotions often occur through relationships of interest, namely the relationships of caring or attentiveness that may form regarding your family, friends, colleagues, or neighbors. For example, my friend Chloe Silverman, an assistant professor at Penn State University, has just published a book looking at the ways in which affect can shape the definition and treatment of autism in children. She argues that parental love, labor, and relationships of care have influenced how autism has emerged as a specific diagnosable disorder over the past 50 years, and how parents have collaborated with biomedical practitioners to develop and test new therapies. Because parents are concerned about the growth and fate of their autistic children, they increasingly demand a part in autism research, defining and changing the dominant biomedical discourses of emotionally neutral, technical language and expertise. Their emotions play a role in helping generate and stabilize new configurations of scientific facts and expertise. On a collective scale, such emotions can be a powerful mobilizing and motivating force. They can increase your attentiveness as a group, they add to your ethics and sense of connectedness, or can accentuate the feeling of distance. And they can signal important concerns about how technologies or science are affecting you. I will make a series of 3 observations now to catalyze an exothermic reaction, a reaction that produces heat. Later, I'd like it to open the room for discussion. Right. Next session is titled Chemophobia and Tolerance. The history of public understanding of chemistry is interesting to follow. For now, I will say that the beginnings of the chemical industry in Europe and the US, there has always been a degree of community resistance to producing chemicals. In Britain and the US, the first environmental regulations grew out of resident complaints about factory pollution in the mid-19th century. Nonetheless, until the mid-1970s, chemical companies and academic chemists had accumulated significant public credibility and trust, largely because of their scientific knowledge production and seemingly never-ending array of new products. Following a string of highly visible polluting accidents in Europe and protests against US chemical use in the Vietnam War in the 1970s, chemical companies began losing their reputation. This trend accelerated with the uncovering of hazardous waste sites across America and the Bhopal chemical release disaster in 1984. In my PhD research, I looked at 30 years worth of industry news, and it was fascinating to see how the industry began using the word chemophobia to dismiss the legitimate concerns of lay people about their health and environmental quality in the early 1980s. This diagram of mine illustrates some of the many examples I'm going to pause for a second and just take a look at these examples of chemophobia because my talking is probably expecting. So here I want to stress that I'm not saying that chemicals are negative or environmentally damaging in full. My point of view is that chemicals are needed and can be made more sustainable. Clarification. So as we were saying before, this diagram of mine illustrates some of the many examples attached to the phrase and what industry typically says. So for example, here's about factory pollution. We take all safety precautions in chemical production as safe, categorically. We need pesticides to feed the world. There's no proof of harm. It's all scientifically unverified. Numerous examples of this are mentioned. And as you'll see, even newly emerging concerns about chemical exposures, as measured in biomonitoring, are described as well as chemophobia. The industry blamed its declining reputation on unwarranted emotive feelings held by non-scientists on inadequate understanding of chemistry and on the media's habit of exaggerating harms. Neil Iceberg, who edited the British chemical industry trade magazine, wrote, "The chemical industry's reputation with the general public, once extremely high, has fallen to an all-time low as a result of accidents such as Bhopal and Seveso, and health scares fed by campaigns by environmental groups encouraged by sometimes gullible media." End quote. A common response to this chemophobia among chemists is frustration and anger at how they believe they're being portrayed. The misconceptions that lay people had could be rectified by providing them with factual, accurate information through advertising, public education needs, and stigmatizing mistaken protesters or biomedical conditions. In short, chemicals exemplify the diversity of discourses about risks, but also the power and politics involved in framing and communicating risks. There's a growing literature on how emotions can shape risk perceptions, but this is incomplete. It's certainly true that emotions can be a poor guide to the veracity or rationality of the knowledge claim. Yet industry argues that any opposition is emotive, even though its responses are emotionally grounded and potentially unscientific as well. There's a deep asymmetry here. Emotions of industry actors are positive and important, whereas those of lay actors are irrational. One of my colleagues at the Green Chemistry Center pointed out that manufacturers sometimes use advertising images of risk-taking activities, such as skydiving, shown here in the slide, or driving fast cars to encourage consumers to accept risks voluntarily. If people think they're volunteering, they feel differently from when they believe they're being coerced or involuntarily exposed. Risk-taking is seen as good for business, but the companies may not care much about the consequences. If you look at industry's discourses regarding chemical risks, you see that these often emphasize that people have the freedom to accept what are meant to be very minimal risks. Alistair says he has to thank Joe for the point.
I'm not skydiver
So in short, chemicals I would like to juxtapose a different perspective. It is remarkable that people tolerate so much chemistry as part of their lives and don't fear chemicals as much as they might. We are, as you can see in the slide here, surrounded by chemicals. And you know, this picture really demonstrates all the chemical-made products present in a household, in all aspects of life. We wear chemicals, type on chemicals, cook with chemical-coated pans, and daub on cosmetics. Yet for decades, we have rarely protested against or even noticed this ubiquity. This suggests an important epistemological paradox. We have some industry and chemist actors claiming that there is chemophobia, yet at the same time, there's widespread acquiescence to the chemical world that corporations such as DuPont foresaw back in the 1920s. So the question is, how did this entrenchment come about? Which brings us to the second observation. The entrenchment of chemicals in our world has occurred because of the proliferation of consumer products based on chemicals, the power of industry in designing processes and products, but also because of consumer demand motivated by perceptions of modernity that are interwoven with emotions. This is not about advertising. It's about how people encounter chemicals. We aren't just surrounded by chemicals, we're also exposed to smells, tastes, textures, and sights of chemicals as sensory artifacts. Historically, these experiences have become a marker of the intrusion of modernity into our lives. They also evoke emotional responses and memories in us, both collectively and individually. We believe that we're modern because we can identify these sensations. Instead of smelling and feeling wood, steam, and gas lamps 120 years ago, we sense chemicals now. It has been said that chemicals are not like industrial pollution in its traditional forms. There usually is no smoke, as people commented on one of the earlier slides. Smell or visible appearance, we can't see contaminants. Nonetheless, this is not entirely an accurate point of view. The new car smell is the most notorious example of chemical experiences. In the past, when people bought a car, they would know that the car was still new because of the fumes emanating from its interior. And that smell is due to the off-gassing of chemicals from the seats, dashboards, door linings, all the materials that make up the inside of the car. You know, the modern car interior is almost all plastic. Typically, the smell wears off within a couple of months. And as Chemical and Engineering News put it in 2005, and I quote, "There's something about the smell of a new car. To many people, the leathery, plasticky aroma that hits you when you slide behind the wheel is a pleasurable scent, seductive, perhaps even addictive. There are even sprays that can reproduce this smell after cars have settled down. And the new car scent, get in a bottle, spray it on. However, the smell is also associated with hazardous chemicals, such as plasticizing phthalates, flame retardants, or volatile organic compounds from sealants and adhesives. In 2001, Australian researchers discovered that 30 to 40 suspected endocrine disruptors and carcinogens can be emitted in new cars. Environmental health NGOs, such as the Ecology Center in Michigan, now associate the new carcinol with connotations of toxic exposure and cancer risks. There is some scientific evidence of adverse physiological responses to toxicity. Some car manufacturers have begun eliminating the chemicals, though there's no compelling consumer demand for it. And on that note, I'd like to open up the floor again real quick for your responses to this question. What smells or experiences come to mind when you were thinking of products or chemical uses in your own life? We get a couple of examples.
I think initially that ammonia is probably the most notable chemical that is household in nature. And,
Ammonia. Anything else?
Coffee.
Coffee. There we go. For me, it's always that kind of plasticky taste that I get in bottled water. Any more?
Personal care products, right? Soap, shampoo, clothes.
Yeah. Deodorants. Intentionals. So, I mean, as you can see, there are many other examples of odors and sensations associated with products. New plastics of any kind. PVC curtains in showers, detergents, soaps, new shoes and clothes, air fresheners, shampoos, as cosmetics like nail polish and special nail polish remover. Often products have odor-producing ingredients added to them that are artificially made. We're also used to the plastic feel, the sounds, and the look of the keyboards that we type on, the food wrappings that our food comes in, the fabrics that we wear, the non-stick pots we cook in. One particularly hidden area of chemical use is in food production. Chemicals are widely used to preserve foods to survive in the ever-lengthening supply chains of the modern food industry. We might not experience the chemicals directly, but we do encounter them through the fresh-looking tomatoes in the supermarket that we've come to expect. An even more important emotional association is between plastics and modernity. As the American historian Jeffrey Michael points out during the initial introduction of plastics from the 1910s onward, consumers were uncertain and afraid of this new class of materials. They didn't know how to use plastic objects. They would leave plates melting on stoves, for example. Plastics were regarded as cheap and poor quality compared to existing wood and metal products. In short, they were disposable. But in the succeeding decades, consumers grew infatuated with what the new designs could offer. Light, colorful, clean, robust, convenient, modern objects that departed crisply from the decrepit, anachronistic materials they were accustomed to. Monsanto even built an all-plastic house in the future in the 1950s that was portrayed as supremely modern. As you can imagine, these properties evoke strong emotional responses. Now, plastics are frequently used for expensive products like laptops or automobiles. They still seem modern to us. It's unclear how far all these chemicals may pose risks to human health and ecosystems. There are certainly many indications of endocrine disrupting chemicals interfering with development and reproduction of humans and wildlife. The key idea is that these sensations have become so normalized that we are oblivious to them and accept them as part of our lives. We could treat them as signs of harm, but we tend not to. Yet, if we don't find these sensations in our lives, if we feel incomplete or deprived, or what? I'd be interested to hear what you think here during this talk. So the final observation that I'd like to make is that despite the entrenchment of this chemical world, green chemistry has nonetheless emerged as a new social movement among some chemists and managers. While most chemists prefer to separate science from politics and policy, even though in practice, as many of you know, they are deeply enmeshed, and to eliminate all traces of affect from the publications, many green chemists explicitly acknowledge that they feel awkward about the legacy of their field. John Warner, an important figure in the field mentioned earlier in the talk, says that he was motivated to take up green chemistry by his young son's death. Another leading green chemist, Terry Collins, says he's motivated by the desire to build a more sustainable civilization. Thus, they are moving closer to accepting that there are legitimate concerns that lay people can raise. Equally important, we are witnessing the development of a small number of civic rebellions against chemical use built by invoking relationships of affect or emotion. In the past 15 years, we've seen a range of lay actors constituting new relationships of affect around product use. These relationships may extend care and concern to children, families, friends, neighbors, and community members. They help justify new forms of intervention and participation. For example, asserting power through expressing emotions, claiming the right to stop using a product. They also break up the normalization of chemicals as part of our environment by bringing how we feel about chemicals into a more critical view. One example is the recent flurry of campaigns, boycotts, legislative action, litigation, and voluntary company actions around bisphenol A, or BPA, a chemical widely used in plastic bottles to stop them shattering easily, but which is also an endocrine disrupting substance. These efforts are often couched in the language of parental concern, particularly for baby bottles. For instance, the Seattle newspaper reported in 2008 that one Meg Robustelli had heard reports that a chemical in most plastic baby bottles could be dangerous, but she had not done anything about it. That's when her mother stepped in and bought her glass bottles. She's an alarmist, but I'm grateful, said Robustelli, whose daughter, Mia, is 14 months old. I switched because of all the concerns about the plastic. Interestingly, this is a case of reviving older material, glass. Rather than presuming that chemicals are the only material we can use, we have a range of alternatives. Parents are beginning to build a new memory of what can be very technical scientific data about the toxicity effects of BPA, and to create a new manufacturer ethics. Instead of selling bottles that all contain BPA and giving parents no choice, manufacturers should make different bottles. And because parents are responsible for safeguarding their children, they should be heeded. However, as we're going through this story, it's important to keep in mind that these relationships of affect are still quite small in number, at least in the US, where few parents have explicitly called on manufacturers and retailers to withdraw BPA bottles. Rather, these actors have responded to increasing scientific information about BPA toxicity, as well as biomonitoring that shows ubiquitous exposure to BPA among Americans, which they believe could lead to lawsuits of boycott by parents. The point, though, is that for the first time, companies are intervening to adopt alternatives that create greater demand for green chemistry, because emotions are playing a role. In Europe, relationships with affect are often invoked as part of NGO campaigns to reform chemical regulation. Grandmothers, mothers, fathers, husbands, wives, and children are asked to express their care for each other by supporting demand for safer chemicals. In turn, relationships of affect may be important in instigating rebellions by workers. The geography and spatiality of responses can signal the existence of environmental justice problems across society. Think of the many workers using toxic chemicals in their jobs. Janitors, cleaners, dry cleaners, painters, nail polish salon workers, miners, and nurses. They're disproportionately exposed to toxic chemicals compared to other population groups. There is some evidence that they can have higher rates of occupational health problems as well. Myself, I support Wages, an open-based NGO that provides jobs for poor Latino women in green cleaning and cooperatives. According to the women who work for the cooperatives, they felt physically ill and depressed when they used toxic cleaning agents. Ironically, they may do so because other more privileged people feel emotions associated with cleanliness. They work because their employers respond to culturally mediated demands for pristine workplaces and houses. They develop relationships with affect not just with the chemicals, but with each other as collectively exposed. This is a quote from the Wages website. What Alita appreciates most about her job is how she feels on a day-to-day basis. The best thing about the co-op is the non-toxic products we use. They don't make me sick and they don't damage my hands. When I worked as a janitor, the boss would give us a strong liquid to use in the toilet. It burned our eyes, and when it dripped on our hands, it burned like hot water. The products we use here are natural, they don't hurt us. So in short, focusing on emotions can empower these workers' voices and trace the exposures and potential health impacts across the society. Whereas green chemistry typically emphasizes the technical discourses and expertise of science, relationships of affect aren't yet accepted as a source of knowledge, but could signal where green chemistry needs to look. So what have emotions got to do with green chemistry, not just chemicals? How could affect contribute to green chemistry? I'm going to conclude with a few nascent thoughts. One way to think about this is to analyze how different groups of people and organizations, ranging from chemists, companies, legislators, consumers, to managers, experience chemicals and green chemistry respectively. All these groups have accelerated that. All these groups have accreted legacies of memories and emotions, indeed, bundles of attitudes and motivations that can create inertia in the chemical production system. Some legislators fear losing industry's donations. Some companies are afraid of chemophobic. Many consumers are used to the plastic products they use, and many chemists disdain sustainability as politicized. In turn, people currently don't know how green chemistry would differ from what they've already experienced as part of their lives. One last slide here. So building on this analysis, we could look at these ideas. We could build new relationships of affect with green chemistry. For example, we can encourage business managers to take responsibility for human and ecological health through institutional changes. If businesses and chemists feel more responsible, they may have more motivation to change. We could acknowledge that the design, production, and use of chemicals are permeated with dimensions of effect. Here I think of the asymmetry of industry emotions favoring risk-taking, whereas we could have risk stifling or Thirdly, we could change the experiences of chemicals to include expectations of what green chemistry can offer, while keeping in mind the vexed politics of defining sustainability. We need to constitute new memories and new experiences by bringing people into much closer contact with green chemistry. And lastly, I'd like to throw out there that we could incorporate affect as part of the larger decision-making and evaluation processes for governing chemicals. I don't mean that emotions should be allowed to prevail over substantive data, but that emotions may be important indications of societal concerns and environmental justice problems that would otherwise be submerged within these technical discourses. Recognizing affect can also help create space for agency by a more diverse range of participants, bringing in parents, grandparents, friends, and neighbors once again. So that concludes the talk, and I would now like to open up the floor for discussion. I'm curious about your action.